Hello, year 10. Thank you for being here, watching the video. If you're watching this, you are one of the fortunates that you are going to be prepared for the Kahoot. In this video, we are going to revise a little bit of factorization, and also we are going to see a new part, which is graphing quadratic expressions. To be honest, I wanted to do this video because in this way, we can be more exact with the content of what we have to do in the class. Now, in the class, we have seen difference of squares. This topic is, I already explained how it works. This comes from a formula where we can write it like this: a squared minus b squared. And as a result, we are going to have a plus b and a minus b. Now, we are going to make some exercises of this in order to review a little bit. Let's go with a very simple example. For example, every time you got something square and you have a number, you are supposed to transform everything to look like the formula. For example, in this case, x squared, it's already like in the formula, but 9 we have to write it like 3 squared. So now in this case we have a for x and b as a 3. Following the formula, we will have to rewrite this into parentheses. A plus b, we have a, which is x, plus b, which is 3, and a minus b, which is the same but with minus sign. Now, like everything in math, it's always going to get more complicated. So let's do something a little bit more challenging. For example, what happens if you have something like this? Let's say we have 16 minus y squared over x squared. This type of exercise will challenge you because we have to remember some of the properties. In this case, if you do not remember, we have to follow certain properties of exponentials. If you remember, when we have things like this, the exponent used to be distributed like this, but in this situation we are going to be in the opposite way, which means that this part we are going to write it like y over x in a parentheses square, and the 16, of course, we have to write it like 4 squared. Now you may realize, but Marco, mister, what is the formula then? Well, if you realize in the formula, this is going to be a, and this is going to be the letter b. Following the formula, we can finish it like a plus b, or 4, let me change the color, 4 plus y over x and 4 minus y over x, and we are done. Now, again, this can be more challenging, but sometimes can be tricky. For example, what happens if I write you something like this? You may realize, Mister is almost the same like the first one, but this is addition. Yes, it's addition, but you have to be careful because we don't have a formula for this. So if in your exam you have something like this, we just write, we just don't write anything, or we can write not factorizable. You cannot factorize this, it's impossible. There is no addition of squares, only difference. If you take a look closer, this is addition. We don't have addition of squares. Following with the other type of exercises, one type of exercise that you are going to encounter in your exam are going to be the ones that we have to fully factorize. That's why it says fully factorize. When you have to fully factorize something, it means that you will have to do this process more than once. Let's put it in an example. Let's say we have y to the 4th power minus 16. Well, let's remember a little bit of the properties in exponentials. Y to the power of 4 is not something square. You take a look here, it's something square, but here we don't have something square. So what we have to do before we start this is to write something. We are going to write something square, but it has to be the same as this. In this case, we are going to take the same exponent, but we are going to divide it by 2. Sorry for that. We are going to divide it by 2. Why is that? So pay attention to remember why that happens. It's because we have a property that says whenever you have an exponent, parentheses, and there is another exponent, what happens with those exponents is that you are going to multiply them. For example, let's say you have 7 to the power of 2, and then you have a parenthesis and another exponent. What is going to happen with 2 and 3 is that they are going to multiply. So we multiply them. So we are going to use this property in our favor, which means that we are always, and please remember, always write the exponent 2 outside. We have to write it the 2 outside, and we need to look for a number that multiply it by 2 will give me, in this case, 4. So to be convenient, of course, it's going to be 2 times 2. Now, this 2 outside is always going to be the 2, the square. Now, we have 16. It's pretty easy to see that. We have to write it like 4 squared. Now, following the same formula, this is going to be A and this is going to be B. And following the formula will be a result of y squared plus plus 4, and y squared minus 4. Now, if you take a look here, we can continue doing the formula, especially when we have subtraction, the difference. In this part, you can see that here we still have a square, and therefore we can obviously make it a square. So I need your attention, especially in this part. Now, in this part, we can continue doing the factorization, the formula. You can even look at it like it was another exercise. We can write this y squared, and instead of 4, write it as a 2 squared. And if we factorize it, it's going to be y plus 2, and y minus 2. But hey, don't forget, we still have this, so we have to write it as well. Now you can see the whole answer is this. These blue factors came from here, and these 2 factors came from here, as you can see. So it's like you split it like into parts, and then this part you split it again. Now be careful, you only can make that if only you have subtraction, a difference of squares. Please keep in mind the formula is with minus. With minus, it's never with plus. So let's try to be something exaggerate, just to be clear. If we have something, let's say we have a to the power of 16, and we have minus b to the power of 24. What we have to check out is that these two, I can write them like something squared. For example, a, I know this looks crazy. I know in your mind you're like, the mystery he got bananas. Yes, I got crazy. This can happen, but you have to be clever enough. You have to be clever enough to see that this little guy, I can write it like something to the power of 2, which is the half. The half of 16 will be 8. Then we have the half of 24 is going to be 12, so we can just write it directly. Okay, we follow the formula. As you may realize, this is going to be A, this is going to be B. Let's follow the formula like it says in here. So we are going to write it like A to the power of 8 plus B to the power of 12, and we have to do the same but with minus. And as you may realize, again, we can continue doing the same with only this part. If you take a look here, if I focus in this part, I can rewrite this section, this other factor, as a to the power of 4 to the power of 2, and the b to the power of 6 to the power of 2. You can see that I'm taking the half and half again. So as you realize again, this is like in the formula we have a squared and b squared. Now, if I factorize this, what is going to be? A to the power of 4 plus b to the power of 6. Then we have a to the power of 4 minus b to the power of 6. But don't forget, we still have this part. Whoa, so as you can see, these two factors, they came from this, and these two factors, they came from this. And believe it or not, we can continue doing the same. I want you to focus on this part. Here, a to the power of 4, I can write it like a to the power of 2 to the power of 2. And the b, we can write it like b to the power of 3 to the power of 2. Therefore, this is, again, like the formula, a squared minus b squared. So, we can continue doing the same. A squared plus b to the power of 3. And here we have a squared minus b to the power of 3. Now, what is going to be the full answer? Don't forget we have these factors. This is going to be the full answer. Look, these factors. We have 1, 2, 3, 4 factors in total. These 4 factors, they came from this. But can we continue here? We have a squared. That's true. We have a squared. But the b cubed, or b to the power of 3, doesn't let me continue. So, of course, I'm not going to continue because this is not something that can be squared. So, let's continue. Let's continue. Okay. Now, well, this is the type of factorization that we can find in the class. Things that can be more difficult, maybe they may look like this. Let's say I will take it from El Baldor. You know, I love that book, Algebra Baldor. Well, in this book you may find some expressions. Let me find the ones I wanted. Some expressions like this. Okay, So expressions like these, they are still quadratic functions because they have the square, but they are a little bit odd because you can see they have parentheses. So let's try to solve the first one. For example, we have x plus y squared minus a squared. But you don't have to be afraid of these type of things because we still are using the formula. The only difference is that a, according to the formula, is going to be all of this, and b is going to be this. So if we follow the formula, we can use the formula like a plus b. It will be x plus y plus a, and we have the other part, which is x plus y minus a. Here, sorry for that. And as you may realize, it doesn't look good when we have this couple of parentheses. Well, we are missing the parentheses, in fact. So we need to put the parentheses here and here. So now it's something that we can work with. Now let's arrange this because we cannot leave it like that. This is the same as writing x plus y plus a. And here we can write it as x plus y minus a. And that's it. Mister, maybe you can put something more difficult. Yeah, there is a bunch of them here. But it's always the same type of things. Literally, you can take the most difficult one in this book and it's going to be the same process. Okay, this one may look easy, but what if we take out the last one? Sounds crazy, right? If we take the last one, well, we can rewrite it. 34. We are going to have 36 m plus n squared minus 121 and minus n squared. Now this may look I don't know, ridiculous, but it's the same logic. The 36, we can write it like 6 squared. We just copy the same things. M plus n squared. 121 is 11 squared. We copy the same. And minus n squared. Now, if we write this in order to be a squared minus b squared, it's going to be the following thing. We are going to have 6 parentheses m plus n. The whole thing is going to be all squared minus the whole thing, which is 11 m minus n, also squared. Yeah, this is a little bit big, it's a little bit awkward because it's a huge expression. It is. Now, you may wondering, why did I take the 2 outside? I took the 2 outside because we have the same here and here, therefore I can put it outside. And the same happens here. We have the 2 here, the 2 here, and we can put it outside. This is the opposite operation of distributing the exponent to each one of the factors. So instead of distributing, we are taking away. We are taking it out. Now, in this expression, we can call this a, and we can call this b. Therefore, we have a squared, well, the square is here, and b squared. Let's write the formula. We have 6, which is, well, let's write a, which is 6m plus n, a plus b. We have b each this thing. And we are going to do the same. We are going to copy and paste the same, but instead of add, we are going to put minus. But now you can see this is flying around. Let's put the parentheses. Now we are not done because we need to get rid of these parentheses. So let's write it. 6 times m is 6m. Yes, we have to do the operation that is inside. 6m, we have 6n, 11m, and minus 11n. Here we have to do the same. You may realize it will be the same, but the sign is going to change. Minus 11m. Minus and minus is just plus. And here we put the parentheses. And we do the operation. We have 6 and 11. We are going to be 17m. Plus 6 minus 11 will be minus 5n. We continue with this. 6 minus 11, it's going to be negative. 6 minus 11 is minus 5n. And 6 plus n is just 7n. Now, this doesn't look pretty. At least for me, it doesn't look good. So I'm going to copy paste. And this I'm going to put it in order. This is going to be minus in the right. And we have this other one here. Now we have finished the exercise. As I told you, we have followed the same principle. We have followed the formula. This is AB. Here we have A plus B from the formula and the A minus B from the formula. Well, this is if you want to be my enemy, I will give you this type of exercise. This is the answer. Now let's continue. We are going to do some of the hard exercises of ABC. Well, ax squared, bx, plus c. This expression, we know it as the cross-section method. In this expression, we are going to work a couple of hard exercises. For example, well, they look like this, but in fact, well, we are going to factorize these ones. Let's start with a difficult one. For example, let's say we have something like 11. We have x, let's write x to the power of 10 plus 5 plus x to the power of 5 minus 20. Now, you may realize we don't have the square here, but we can write this like it has a square. Instead of writing x to the power of 10, we are going to write it as x to the power of 5 to the power of 2. Now it's the same. Plus x to the power of 5 minus 20. Now, as you may realize, this x to the power of 5 is the same as if you were writing just x. Because we have something squared. Something squared. Here is the same. We have something x squared. Here we have the same thing. Let's suppose this is a squared. What is this? A minus 20. It's the same, but instead of a, we have x to the power of 5. Now, following the logic, we are going to find two things that will give me x to the power of 10, which is almost always the same thing, x to the power of 5 and x to the power of 5. This multiplied, if you multiply this, don't forget, what is going to happen is that you can add the exponents. Now, we need to look for two numbers that multiply will give me minus 20. In this case, minus 4 and plus 5 are the best option. Now remember, we have to cross, and let's find out what we have in the middle. We will have minus 4x to the power of 5 and 5x to the power of 5. Minus 4 plus 5 is going to give me x to the power of 5. This thing, ladies and gentlemen, is the same as we have in the middle, which means that in the middle we are going to have these two factors. We are going to have x5, or well, x to the power of 5 minus 4, x5 plus 5. And we are finished the exercise. This is like the hard version. Now let's continue digging on this. Let's try to do something that looks a little bit more difficult, maybe odd. For example, in my opinion, I see number 21, well 22. It says x4, y4 plus x2, y2 minus 132. Alright, so you may realize this part in the beginning is just x squared, y squared. All of this is going to be a square plus x squared plus y squared minus 132. Again, this is like saying a squared plus a minus 132, where a represents this. Okay, we are just putting more and more letters so it looks ugly and awful. So again, we need to look for two things that multiply by themselves. They will give me this. You may realize it's always the same. Literally, we write the same twice. But now the important part is where we have to find two things that multiply by themselves. They give me 132. So if I were you, I would take the calculator. Sorry for that. If I were you, I would take the calculator. And if I need a number that multiply can give me 132, I will take 132 and I will try to divide it by the numbers. Let's say I will try to divide it by 9. Nope. I will divide it by, let's say not by 9. I need to look for more numbers. I know that by 2 is going to be 66. So I know it's related to 11. Maybe if we divide it by 11. Oh, very good. So we know that 11 times 12 is 132. We are going to play with those numbers, 11 and 12. Now, 11 minus 11 times 12 is going to be minus 132. We can go crossed. And yes, you may realize this is going to be 12 x squared y squared minus 11 x squared y squared, and this is going to be just x squared y squared. Therefore, this is the same thing we have in the middle. Good. Then what is going to be the answer? Well, the factors x squared y squared minus 11 x squared y squared plus 12. This is the answer. Okay, well, this is like the hard versions of this type of factorization. If you are still here, congrats, I'm very glad. I need to take the time here because now we are going to start a new part. Here we are in the 30 minutes, okay? 30 minutes. So after this time, you will be looking for a new topic. Now, before continue to the new topic, we need to know something, which is called completing a square. Completing a square means the following thing. To understand that, we have to be aware of this. A square, we have x squared, etc. If we take, for example, x plus 1 squared, this doesn't, let me put maybe not 1, let me put 3 instead. Most of you made this mistake. Okay, you write x squared plus 3 squared. This is completely wrong. Never do it. This thing is the same as writing x plus 3 and x plus 3. And if you realize here, we have to do distribution. And here, sorry for that, we are going to use a general formula. A and B, we copy the same. They are going to be multiplied by distribution. A times A is just A squared. A times B is AB. Then we have B times A. B times A is AB. And B times B is B squared. You realize here, what do we have? A squared plus 2 times AB plus B squared. Now, this is the general formula for this. If we change this to minus, this is going to be minus, 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 and minus 2. So, a square that is like this, it's going to have this shape. Alright? Now, when we have to complete a square, it means that we need to look for this type of thing. So, usually the quadratic expressions, they doesn't look like this. For example, let me put you an example where we have to complete a square. The order is the same, completing a square, complete a square, complete the square of the following quadratic expressions. If we want to complete the square of a quadratic expression, the expression is going to be, for example, something like this. Let's say we have 4x and plus 5. Okay, so we need to, from this, we need to get to something that looks like this, in this way. You may say, oh, we can do the thing, the cross method. When we have to complete a square, it's nothing about that. Listen, when we have to complete a square, it's a little bit more, it's different. And here I need your full attention. When we have to complete a square, it means that we have to focus only in these parts. Only in these parts. Okay? So let's copy them again. Now, we are going to take this number in the middle, 4, and we are going to add it. So we added the 4. Yes, we add 4. Okay, so let me write it step by step. First, add the number in the middle. What is the number in the middle now? 4. Second, this number in the middle, we are going to divide it by 2. So we add the number in the middle, then divide it by 2. Alright? And we didn't finish. Sorry, it's 3 things. After we divide it by 2, we have to square it. So it's 3 things. We add the number, we divide it by 2, and we square it. So here, let me write it. Finally square it. So we write a square. Now this is going to give you a result, but we are going to do the following thing. This is the next step, the step number 2. Then subtract the same number. What it means here is subtract. This number we are going to copy paste, but instead of adding, we are going to subtract. Why do we have to subtract? Because in this way, this can cancel out, and it's going to be the original exercise. Don't forget we have this number 5. Okay. Now, let's write it. Let's try to write it, but we are going to divide this thing in the middle. Let's divide it. And here we are going to have the same, minus 2 squared plus 5. Oh, now this thing, this whole thing, is going to be what we call in math a perfect square. This is a perfect square. What are the characteristics of a perfect square? A perfect square means that we can take this and write it in the following way. We have x, we have 2, and we can write it like this. Guys, we have only to take the x, we take the 2, and we take the sign in the middle. Okay? The x, the 2, and the sign in the middle. And we have to square it. Now, this result is going to be minus 4 plus 5. Now we have completed the square. This is going to be the same expression that we have, but in a way that is in a complete square. Completing a square means that your result must be like this, in this way. Let's try to do another example, and I will try to be more clear about this. Number 2. Here in number 2. In number 2, let's say we have x to the power of 2 plus 10x minus 11. So we are going to follow the same rules. Add the number in the middle. Okay, we copy this. Let's follow the rules. Add the number in the middle. Divided by 2. Square it. Subtract the same number. Don't forget that we still have the minus 11 here. Okay, so this is going to be, again, all of this is going to be what we call a perfect square. So if we do the following thing, this is going to be 5 squared minus 5 squared. Again, this is going to be a perfect square, and a perfect square, what do we have to do? We take the x, we take the 5, and we take the sign in the middle, which is plus. And we, of course, have to square it. What do we have outside? We have 5 squared, which is 25, minus 25 minus 11, which is minus 36. And we are done. Remember, what we are doing is complete the square of the quadratic expressions. We are not factorizing. And well, this is completing the square. I will say the easy part. Again, completing the square, like everything in math, it can turn into something more difficult. But I think we are going to leave it until this part for now on. Okay. The class of tomorrow is going to be more related to this complete square. Also, we are going to see some of graphing a quadratic function. Thank you for watching. This is only the first part. I hope we are going to continue more parts. Well, if you watch this, you have a lot of advantage for the Kahoot tomorrow.